Okay guys, this is Mr. Gilmore here, putting that video together of the other extended response question from the measurement review questions. So this is, if you go to the measurement chapter, this is in the review questions, the extended responses, it's question 2. Just bear with me because this is the first time I've made a video like this, and also the first time using the writing tool that I'm using, so it might be a little bit messy. It's also a bit weird recording yourself, so just bear with me a bit, but hopefully we can make the most out of this. Alrighty, so a circular school oval, as we can see drawn up here, has a radius of 50 metres and is marked with spray paint to form a square pitch as shown there. State the diagonal length of the square. So the diagonal length of the square is going to be here to here. As we can see, the corners of the square lie on the circle. If we know that the radius, which is going to be this length here, is 50 metres, I'm just trying to write that out. So we know that R equals 50 metres, then the diagonal length is going to be the full length across, which is going to be the diameter of the circle, which is obviously 2 times the radius, which equals 100 metres. So therefore we know that, just for so 2 part A is 100 metres. Obviously always very important to remember your units. Alright, so use Pythagoras' theorem to find the side length of the square in exact surd form. So I'm going to draw this diagram up nice and big because I always like to use big diagrams because it's just a bit less messy, you can make it a bit neater. Obviously my diagram is not fantastic because I don't have a ruler with me. So we know this is a square, so all these sides are the same length. We know that this length here is 100. Lovely. So we want to find, the question is, use Pythagoras' theorem to find the side length of the square in exact surd form. So the side length of the square is going to be either of these two sides here. So if we draw this triangle again over here, so this is question B. This triangle looks like this. As it's a square, we know it's a right angle because this angle here is the same angle as over here, hence the same angle as up here. So this length is 100. This length we're going to call A. As it's a square, we know that this length and this length is the same. So that's that length and that length, they're the same. It's not quite to scale here. So therefore, from Pythagoras, we know that A squared, which is this length here, plus the other side, which is this length here, which is also called A. So A squared plus A squared equals the hypotenuse squared, which is 100 squared. Collect the like terms, so 2A squared, so A squared plus A squared is 2A squared, equals 100 squared. Therefore, A squared equals 100 squared divided by 2. So let's work that out. So on a calculator, just doing 100 squared equals 10,000, which equals 10,000 divided by 2, which equals 5,000. Therefore, I'm just going to move up here. If A squared equals 5,000, A equals plus or minus the square root of 5,000. Let's just keep going because it's hard to erase things on this. And if I put the square root of 5,000 into your calculator. We get a number. However, the question tells us to find the length of the square in exact surd form. So A equals root 5,000 meters. It's plus root 5,000 because we can't have negative length, obviously. All right, so moving on, I'm just going to erase these things so we've got some more space. Obviously, you can go back and pause if you need to look at the working out. The best thing to, I think, get the most out of this is hopefully we are doing these examples in our books as we go through them, or at least watching them back afterwards. All right, so let's just write in what we know in that diagram. We've got our circle, we've got our square in the inside. We now know that the diagonal is 100, and each edge of the square, which I've just decided to call A, which is the same all the way around because a square, every side length is the same. A equals root 5,000 meters. All right, so part C, find the area of the square pitch. So if the square pitch, just for part C, if it's a square and the length and the width are both root 5,000, then the area equals length times width, equals root 5,000 times root 5,000. Put that in a calculator, you don't even need to, equals 5,000 meters squared. So that is our area, it's 5,000 meters squared. So I'm going to pop that up here. Area equals 5,000 meters squared. I'm just going to erase the working out for part C again so I've got some space. Fantastic. All right, so moving on, part D, find the percentage area of the oval that is not part of the square pitch. Round your answer to the nearest whole percentage. So we want to find out the percentage of the oval that's not part of the square pitch. So that's going to be everything that sits outside of the square. So to do that, we're going to work out the total area of the oval. Sorry about the wonkiness, I might do that again. This is part D. We're going to do the total area of the oval. We've got the square pitch in the middle. We only want the shaded areas. So what we can do is have the oval area minus the square area will equal the shaded bits around here. So hopefully we can see that if we get the total, if we just want to get these shaded bits around here, it's going to be the total area of the oval minus the area of the square in the center. So hopefully we remember that the area of a circle, I'll just do a little annotation, that's the circle, equals pi r squared. We know from what we're given up here, the radius is 50 meters of the circle. So therefore it is equal to pi times 50 squared. Put that in a calculator. Equals 7,853.98 meters squared. Now that number is 0.981634. For now, I'm just going to write it as 0.98 to 2 decimal places, but we'll talk about that later on. Moving on, the area of the square, we already know. So the square's area equals 5,000 meters squared, as you can see up there that we worked out previously. We're being asked to find the percentage area of the oval that is not part of the square. Sorry, so we're not actually being asked what is the shaded area, we're finding out the percentage of the shaded area. So to do that, we're going to have the okay, sorry. So to do that, we're going to need to know the shaded area percentage. So the shaded area percentage, so the shaded area we're going to need to know. So that is the area AS is going to be our area shaded, is going to be equal to 7,853.98 take 5,000, which is equal to, just in the calculator, 2,853.98 meters squared. The percentage of the shaded area of the whole oval is going to be, so to do a percentage, we're going to do the area of the shaded divided by the area total, which is the area of the circle, times by 100. So that's going to be equal to 2,853.98 divided by, see if I can just scroll a little bit. Oh, I can scroll. Divided by the total area of the oval, which is 7,853.98 times by 100. So putting that into a calculator, it's going to be so this number here, this division is 0. Sorry, things messing up. 0.36338 times by 100, which is equal to 36.338. However, the question says to the nearest whole percentage, as we can see up there. So therefore, it's going to be 36.338, rounding off to the nearest whole percentage, is just going to be 36%. So 36% for part D. All right, so now moving on to athletics. What does that say? Let me just erase that. Two athletes challenge each other to a one-lap race around the oval. Athlete A runs around the outside of the oval at an average of 10 meters per second. Athlete B runs around the outside of the square at an average rate of 9 meters per second. Athlete B's average running speed is less because he needs to slow down at each corner. Find who comes first and the difference in times, correct to the nearest hundredth of a second. All right, so I'm just going to erase this stuff to make some space, because this one will probably take up a fair bit of space. Lovely. All right, so two athletes challenge each other to a one-lap race around the oval. Let's look at athlete A first. This is athlete A. he has to run around the outside of the oval. So we need to know the circumference of the oval. So we need to know his distance to work out the circumference of the oval. So the circumference formula we should know. And that one is C equals 2 pi r, which is equal to 2 pi times by 50, because if you remember the radius was 50, which is equal to, just putting that into a calculator, 314.159 meters. So that is the distance that the runner A has to run. They're running it at 10 meters per second. So we'll say that their speed equals 10 meters per second. Their D for distance equals 314.159 meters. If speed equals distance divided by time, then time equals distance divided by speed. That's just an algebraic rearrangement. So therefore, time equals 314.159 divided by the speed of 10. Put that in a calculator. You shouldn't really need to, but may as well. So the time is, just erase that. The time is going to be 31.4159 seconds. The question says to the nearest hundredth of a second, so that's the second decimal place. So that's going to be, oh sorry, what have I written? I've written the wrong thing. 31.159, which is going to be 31.4159, which is to the nearest hundredth of a second will be 31.42 seconds. Need to have those units there, very, very important. All right, so let's look at athlete B. So athlete B runs around the outside of the square. So we need to know the perimeter of the square to work out how far they're running. That's just going to be A plus A plus A plus A, which is equal to 4A. A was root 5,000, so let's just say D, which is the distance they're running, is going to be equal to 4 times root 5,000 equals, just in a calculator, 282.84 meters. And that makes sense that they're running less far, because you would imagine that the distance running around here is going to be less than the distance running around there. Hence that this distance here for athlete B is smaller than the distance here for athlete A. Their speed equals 9 meters per second. So therefore, the same formula, if speed is distance divided by time, time is distance divided by speed, just by algebraically rearranging, is going to be equal to 282.84 divided by 9. When I put this in my calculator, this 84 is actually 0.8427125. I like to use that whole longer number in the calculator because it means it's more accurate. So that is going to be equal to 31.42698 seconds. We're doing it to 100th of a second, which is the second decimal point here. So it's going to be equal to 31.4 0.2 seconds. Let's check what the question was asking. Who comes first and the difference in times? Well, unless I've made a mistake, which I better check, we can see that they both arrive, like they both do it in the exact same time. So I guess you could say that no one actually... Oh no, sorry. If this is 0.426, then this is 0.43 seconds. Therefore, our final statement is athlete A comes first. Oops. Difference in time is going to be 31.43, take 31.42, which is equal to 0.01 of a second. So 0.01 of a second. So the difference is very, very small. All right, hopefully that's been very helpful. Please go over these questions with your books, pause it to work out the working out as you go, and see me in class on what lesson, what day? On Thursday, if you have any questions. Hopefully this is uploaded on Wednesday or Tuesday night. All right, thank you for your time, guys. See you soon from Mr. Gilmore. Thank you.